Hello, our most valued student. My name is Confident. Welcome to our 24-minute lesson. This is Mechanotechnology in M3, and in this particular lesson, I want us to look at power transmission, and the main part of the lesson is to look at some basic introductions, and mainly we are going to look at the calculations that are involving power transmissions. Now, before I start this lesson and look at these calculations which we'll be doing in here, I want to first introduce you to the formulas that are most important for you whenever you are in your final exam. Now, the first part of it, in the formula sheet is that you need to go to the back of the paper, and in the back of the paper you're going to find the formula sheet. And usually these formulas do not change, and the formulas that you're going to use under power transmission, it is the first formula which talks about the design power. It is then the second formula about the corrected power per belt, as well as the third formula which is the belt length. These three formulas are the main formulas that you're going to use in your calculations, as well as two other formulas that you need to know by head, and I'm going to show you those two other formulas. The next part of the formula sheet that you need to know, or the next part of the information, is this particular table. It's called table 1. It is the service factor for the selection of wedge belts, and I'm going to show you how you can use this particular table. It is also an important table for you to understand. Also, sometimes they bring questions that involve the center distance. It's got two different types. There is the 16 N SPP wedge belt, as well as the 22 N SPC wedge belt drives. And then I'm also going to show you how to interpret the information. Usually they'll be asking about the correction factor as well as the belt length in these two tables. And another important table, also called table 2, it is the minimum pulley diameter, and I'm going to show you how to use that. So now let us look at a few questions and how we're going to be using those, as I said, those tables. Now let us start with the first question. Now the first question says, as I said, it is power transmission calculations. It is the first question that you're going to find in your mechanotechnology. Usually question 1 is out of 20 marks, and it is one of the longest section in terms of the amount of work that is covered, because it not only talks about the calculations under power transmissions, mainly under belt drives, it also talks about couplings as well as clutches. So whenever you're looking in your book, you must read the power transmission in your mechanotechnology, as well as the coupling of shafts, as well as the clutches. You will find these questions falling under power transmission. Now, to begin the lesson, it says a 105 kilowatt electrical motor which runs at 900 R per minute. The R per minute there means rotation per minute, since it is rotating. So a 105 electrical motor which runs at 900 rotations per minute drives by means of a wedge belt hammer mill at a speed of 570 rotation per minute. And then says this is a heavy duty operation and performs a 9-hour duty per day. A centrifugal clutch is used for a soft start. And then it says design this wedge belt drive by means partly by means of the following steps. So now when they are saying design it, they are now going to be asking you to design it through the calculations. So we are going to look now at the calculations. Now the first calculation says calculate the speed ratio of this drive. Now to calculate the speed ratio, if I can have a blank page there, you need to know the formula for calculating the speed ratio, because they will not give you this formula for calculating the speed ratio. So for you to calculate the speed ratio, this is one of the formulas that you need to go with in the exam. You need to know it by head. It will not be in your formulas. Now the speed ratio, in a simpler way for you to remember it, it is the speed of faster pulley divided by speed of slower pulley. I know you'll be like, this is actually difficult to remember, but now I have a simplified version again for you to remember. Now, if we go to the question, let us go to the question. How do you know when they talk about the speed ratio? The thing that you need to look for is R per minute. So there will be two of them which talk about rotation per minute, and if you can see in our question, we have got the first R per minute and we have got the second R per minute. So when they talk about speed ratio, always look for these two rotations per minute. Now from these two, you now go back to the formula, and it says faster and slower. So now if you're going to look at faster and slower, if you go previously, you have to focus on the bigger number which represents the faster and the smaller number which represents the slower pulley. So if you go to the calculation, the faster was 900 R per minute over the slower, which was 570. So it will be 570 R per minute. So basically, you are looking for the bigger number divided by the smaller number, but remember, it is very important to focus on the R per minute. Now, if I take my calculator so that I can calculate the speed ratio, as I said, it is 900, and then you're going to divide that by 570, and the answer that we are getting, remember, you must round off your answers to 3 decimal places. If you don't know how to do it, you can actually set your scientific calculator to 3 decimal places. You press shift, you press setup, which is the modern setup. Now you look for 6 where it says fix, you press 6, and then when it says fix 0 to 9, these are the rounding off, and you want to round off to 3 decimal places, so you press 3, which means now when you press SD, your answer will be rounding off now to 3 decimal places. So your calculator can do that. As you can see, the answer I'm getting is 1,579. So you write that answer. It doesn't have units because the R per minute also was cancelling. But now this is not the final answer. You have to remember, they say the speed ratio, and your final answer, you're going to say speed ratio is now 1:1,579. This is how you write your final answer. You can then say speed ratio is, then it means speed ratio is 1:1,579. So if you leave your answer as 1,579, if it's 2 marks, you'll just get the mark, but this 1:1,579 will give you the second mark. So that is how you get your speed ratio. As I said, remember, you are not given this formula. You need to remember about the faster pulley over the slower pulley, and by the faster, look at the bigger number with R per minute divided by the smaller number with R per minute. Now, looking again at the next question, it says, refer to table 1 attached and find the service factor for this drive. So now, this is where now we are going to look at those tables, and in this case we're looking at table 1, and they want us to find the service factor for this drive. So now if I go to the tables, table 1 is the table that talks about service factors, and in the service factors there are a few things that I want to bring to our attention. The first thing you need to focus on is the type of the driven machines. Now in the statement they will tell you if you are dealing with light duty, medium duty, heavy duty, or extra heavy duty. They will tell you that. Sometimes if they do not mention about these duties, they will actually tell you about the machinery. For example, they can say a hammer mill. So if they say a hammer mill, you must focus under heavy duty because that's where you find a hammer mill. If they say crushers, you must focus under extra heavy duty. But the key thing is you need to know that there are 4 classes: light, medium, heavy, and extra heavy duty. The next part to focus on under the service vectors, you have to look at the two types of starts, the soft start and the heavy start. Now the soft start and heavy start, each one has got three sections of time, which is 10 and under. Now if they say hours per day duty, if they say 10 and under, means 10 is included as well as everything under 10, such as 9, 8, 7, 6 going down. If they say over 10, do not include 10, it's the number that is bigger than 10, which is 11, and then it says over 10 to 16, so it's 11 to 16, and then over 16 means it's above 16, so that is 17 and above. Same thing on the heavy start, so it is also three categories of hours. So remember, you have to focus on the classes, which is the type of duties. You have to focus on the start, whether it's soft or heavy, as well as the hours per day duty. Now, sometimes students, they confuse heavy start with heavy duty. Remember, you must look at the keyword. This is duty and that is start. So if you see two words repeating heavy and heavy, do not be led to think that it might be heavy duty when it's actually a heavy start, or do not confuse a heavy start with a heavy duty. Now let's look at the question now. It says, refer to table 1 attached and find the service vector for this drive. Now I need to look for that information that is given, three things that I'm looking for. If I can now erase what I was underlining. Now, three things that I was looking for. The first is the duty. It says this is a heavy duty. You can see now. First thing, I know it is a heavy duty. The second thing, I need to know the start. It says a centrifugal clutch is used as a soft start. So you can see it's heavy duty and it's soft start, and the hours is 9-hour duty per day. So this information can help me to find the service vector. So let me repeat again. I'm supposed to look for three things. The type of duty, there are four classes. It's light, medium, heavy and extra heavy. So this is heavy duty. And then also the types of start. There is heavy start or soft start. In this case it is soft start, as well as the the duty per day, it is 9 hours, which means if you remember those three categories, it is 10 and under. So if I go now to my table, they told me it is heavy duty. So now if I can use maybe a straight line, it's a heavy duty. So I'm going to cross and say I'm looking under heavy duty. Now, okay, I'm looking under heavy duty. It's better to use that. The next thing, they told me the type of start is soft. So I'm looking under soft start, which is that part. And the next thing they told me it was 9 hours. So I'm looking at 10 and under, and I'm looking at that. Now, if you look, if I put it on the side like that. Now, if you look at where the cross is meeting, these two lines are crossing each other. You can see that I'm crossing it at 1,2. So the service vector for that particular drive is 1,2. So the answer there is 1,2. So you come here and write, in this case, it says refer to table 1 attached and find the service vector, which is equal to 1,2. So that is how you simply find the service vector. The next question, it says calculate the design power. Now the key word there is I need to calculate, which means there is some formula that I'm supposed to use. So if I can erase now here, because I'm going to do my calculation. They want me to calculate the design power. Now for me to calculate the design power, I need to use a formula. If I go to my formulas, you can see that this is the formula for design power. It says design power is power of electrical motor times service vector. So if I write that formula and say design power it is equal to power of electrical motor and then it says times service factor. So this is the formula for calculating the design power that I'm given. Now I need to find this information, and this information already I know it is given. Where do I get the power and where do I get the service factor? If you go previously, you look at question 1,2, you remember that they said I must find the service factor. So already I've got the first part of the information, which means under service factor I have got 1,2, and I must multiply that number by the power of the electric motor. Now if I read again this particular question, it says 105 electrical motor. So the thing is, I need to find the power of the electrical motor, and you can see now there is a word which talks about the electrical motor, and that power is the number that they're giving me there. That number is 105 kilowatt. It is the power of the electrical motor. So if I have the information I have in there is 105 kilowatt. So now with the calculator, I'm going to be now multiplying the 105 times the 1,2, and the information I'm getting is 126. Now remember, I'm dealing with power. You can see that when it says power of electrical motor, they gave the answer in kilowatt, so I must also leave my answers in kilowatt. So that is how I use the information I'm given to find the service factor. Now let us look at the next question. And the next question, as you can see, question 1.1.2 and question 1.1.3 was related, whereby the information that we used was coming from the previous question. So always remember that some of these questions sometimes are linked. Now let us look at question 1.1.4. It says refer to table 2 attached to and find the minimum pulley diameter. And again, you are going to use the table, and that particular table, it will help us find the minimum pulley diameter. Now if I can go to the tables, remember it talks about the minimum pulley diameter. Do not confuse this particular table. It's also table 2, but it must not confuse you because this particular table 2 is talking about the center distance. So don't be confused by this particular table. As you can see that it refers to center distance for the wedge belt. You are looking for the minimum pulley diameter, and in this case you have to look at this particular table 2, as you can see, where it says minimum pulley diameter. So the focus that you must focus on is the one that talks about the minimum pulley diameter. Now if you go to the question again, the question says refer to table 2 attached and find the minimum pulley diameter. Now you need to study this particular table and see what it actually requires. And this table, it requires two things. The first part, it talks about the speed of the faster shaft, which is the speed of the faster pulley. As if you remember, I said when you're finding the speed ratio, there is the bigger number divided by the smaller number. So you have to take the bigger number with R per minute, which represents the faster pulley. And then secondly, you have to look under the minimum pulley diameter. You can see it talks about the design power, which means you need to know the design power again for you to find the minimum pulley diameter. Now with these two information, if we go backwards, you can see that for us to find the minimum pulley diameter, we need to know the answer from the previous question, which is the design power, as you saw from the table, as well as the speed of the faster pulley. And if you look at the information on the speed of the faster pulley, you can see that the faster pulley is 900 rotation per minute. So we're going to use 900, and after that we are also going to use the answer of the design power. And the design power, they told, if you calculated it well, we said it was 126 kilowatt. So I'm going to use that information to say my design power, in this case dp, but you mustn't say dp, just to shorten it. My design power is 126 kilowatt, and then my faster pulley, in this case, it is equal to 900 rotation per minute. So with this information, I have to now look under the faster pulley for 900. Now there are three numbers I can consider. I can consider 720, I can consider 960, I can consider 1200. Now I need the number that is closest to 900 rotation per minute, and as you can see, it is 960. Therefore, I will use that 960 rotation per minute. The next one I have to consider is 126, and 126 again, I have to consider the number that is close under design power, and you have to look along here. So if I look at 110, 130 and 150, I have to look at the number in which when I round it off, I will get when I round 126, it will be closer to, and you can see that for 126, if you check 110, if you subtract 126 minus 110, it will be 6 and it's 16. And if I subtract 130 minus 126, you can see that it is 4. Then 150 is far, so 126 is actually closer to, 130 is actually closer to 126. So with this information that I have, what I need to do, if I can take a line, I'll do it just below the numbers so that you can see the number. I can take a line under 960, and then I will also take a line just under 130. If I had taken it on top, you're not going to see this number, but I think with this you can see that the number where this was going to cross is that number 300. So this then becomes the minimum pulley diameter. And the key thing, also look at the units. The minimum pulley diameter is measured in millimeters, so the answer there is 300 millimeters after using the table. So when you write your answer, you are going to say, in this case, minimum pulley diameter is equal to 300 millimeters. So that is how you use the information given to find the minimum pulley diameter. So that's how this calculation work.